This is Southwest 212. Let's do some more math. All right, let's read this all the way through, and then we'll start answering the questions. The ratio of the corresponding side lengths of two similar rectangles, rectangular tables, is 4 to 5. So I'm just gonna draw a little picture. Here's a rectangle. Here's one that's just a little bit bigger. We know this 4 is going to go with this one, and the 5 is going to go with this one. Just the corresponding side lengths. So let's maybe label this a 4, and label this a 5. So we got ourselves a little picture there. What is the ratio of the perimeter? Of the perimeters? That's the same as the ratio of the side lengths, because a perimeter is simply all the side lengths added up. So I know it is 4 over 5. B, what is the ratio of the areas? Well, to take a perimeter ratio, you can actually turn it into an area ratio. You just take the numbers and square them. So you would do 4 squared over 5 squared. If you don't know what that is, that's just 4 times 4 and 5 times 5. So the new area ratio is 16 over 25. And now I have an area ratio. Part C. The perimeter of the larger table is 44 feet. What is the perimeter of the smaller table? So I know the larger one is 44, and I don't know the smaller one. I'm going to call that X. I'm going to set it equal to the perimeter ratio that I already have right here, because it's comparing perimeters. But I'm going to have to switch this around, because I put bigger over smaller. I'm also going to have to put bigger over smaller. I know this perimeter, I don't know this one, but I know the side lengths are 5 to 4. So let's cross multiply. So 4 times 44, we get 176. That equals 5 times x, which is just 5x. And we'll divide both sides by 5. So 176 divided by 5, and we get, 35.2. That is the perimeter of the smaller shape. That's what it wanted, the perimeter of the smaller shape right there. 35.2 if you go all the way around this one with a side length of 4. Just want to give a shout out to Little Papa, Southwest 212, over and out.